Hello everyone, and welcome back to the show. I am your host, ichino-ani, and I am so happy to be here with you today. Let's check the calendar first, shall we? Today is January 26, 2026, and it is a Monday. I hope you all had a wonderful weekend and are ready to learn something new. Today, we are going to dig into a very interesting article from the archive. It falls under the category of optimization and machine learning applications, specifically regarding logistics. For those of you interested in cs.LG or machine learning, this is a great example of how algorithms solve complex real-world physical problems. The title of the paper is a rolling span brand. I'm pretending for the multi-compartment with multiple time windows. Why, that is quite a mouthful, isn't it? Let me give you the code so you can follow along if you like. It is heps://cardiff-1/2601.16194. Now, don't let that long title scare you away. As your teacher for today, I am going to break this down so it is as easy as understanding a school lunch menu. Actually, school lunch is a perfect analogy for this. So, what is the problem this paper is trying to solve? Imagine a delivery truck. Usually we think of a truck as just a big empty box on wheels. Right, you throw all the packages in, and off you go. Our modern logistics is much more complicated than that. This paper deals with two very tricky constraints. First, the trucks have multiple compartments. Think of a bento box or a lunch tray. You cannot put the hot soup in the same section as the ice cream, or everything gets ruined. In the logistics world, this means a single truck might need to carry frozen food, chilled food, and dry goods all at once, but in separate sealed sections. Think about a fuel tanker carrying different types of gasoline that can't mix. The second problem is multiple time windows. This means the customers at grocery stores or gas stations are very picky. They might say, I can take a delivery between 8 am and 10 am, or I can take it between 4 p.m. and 6 p.m., but not in between. So the algorithm has to figure out a route that hits these specific scattered time slots perfectly. The researchers developed something called a rolling span branch and pre algorithm. And basically, instead of trying to solve the entire city map at once, which would take a supercomputer a million years, they use a clustering technique. They break the map into overlapping clusters, solve the puzzle for that small area, and then roll that solution forward to the next area. It is like cleaning your room one corner at a time, instead of trying to clean the whole house in 1 second. Let's talk about how this applies to everyday life. This technology is the brain behind the scenes of things we use every day. Here are 3 specific examples of where this applies. First, let's look at grocery and food distribution. This is the most direct application. Imagine a large supermarket chain. They need to restock their shelves. One truck needs to bring frozen peas, fresh milk, and paper towels. Using the technology from this paper, the system acts like a recommendation system for the logistics manager. Just like a video site recommends the best movie for you to watch, this algorithm recommends the perfect loading pattern for the truck. It ensures the frozen peas go in the freezer compartment, and the paper towels go in the dry compartment, and it calculates the rate so the truck arrives exactly, and the store manager is ready to unload. Without this, you would need 3 separate trucks, which is terrible for traffic and the environment. Second, let's consider energy and fuel logistics. When you go to a gas station, there's regular, plus and premium gas. And maybe diesel. Those huge tanker trucks you see on the highway often have internal diverters. They are multi-compartment vehicles. This paper's algorithm is crucial here. It helps with demand forecasting and route planning. If the algorithm knows that station A needs diesel and station B needs regular, it figures out how to fill the truck's compartments to serve both stations in one trip. It prevents the dangerous situation of mixing incompatible fuels. It is similar to how object recognition works in autonomous driving, where the car must identify and separate different objects like pedestrians and other cars. Here the algorithm identifies and separates different chemical payloads and routes them safely. Third, let's think about medical and pharmaceutical supply chains. This is a more advanced application. Hospitals need various supplies. Some are vaccines that must be kept super cold. Some are standard medicines that just need to be cool. And some are bandages that are fine at room temperature. Also, hospitals are busy places with strict delivery hours. We cannot just show up with a pile of boxes during surgery shift change. This algorithm acts like a high-level scheduler. It is comparable to spam mail filtering in a way. Spam filters sort good emails from bad ones to keep your inbox clean. This routing algorithm sorts through millions of possible bad routes and bad delivery times to find and run clean route that gets all the medicines to the hospital safely, at the right temperature, and at the exact right time. So, how does this compare to other technologies? Well, the paper mentions that before this, companies often relied on manual planning. Imagine one experienced guy, maybe he has been doing it for 20 years, sitting there with a map and a pencil. The paper says this algorithm reduced the number of vehicles needed by 20% compared to the manual method. That is huge. But it also saves huge amounts of money, estimated at $250,000 annually for just one facility. Compared to standard vehicle routing software, which usually assumes a truck is just one big empty space. This approach is much more sophisticated and handles the geometry of the truck and the complexity of the schedule simultaneously. It is like the difference between a basic calculator and a modern AI computer. I find this so fascinating. It shows that machine learning and advanced algorithms aren't just for generating cool images or chatting with chatbots. They're actually out there on the roads making sure our food stays fresh and our gas stations don't run dry. This paper really highlights that making these systems work better, like using a rolling SPAS technique, can make the whole world more efficient. It creates a greener planet by using fewer trucks to do the same amount of work. Alright class, that is all the time we have for today's lesson on multi-compartment routing. I hope you found it as interesting as I did. Be sure to check out the paper if you want to see a heavy math behind it. Have a wonderful Monday, and I will see you next time.